Good afternoon and welcome to today's webinar. We appreciate taking your time out of your schedule to join us today. And today's topic is on achieving sustainability with generative design. If you have any questions that you'd like to ask during the event, please fill them out in the Q&A section of Zoom. My name, Leslie Manasian, and I am the Chief Operating Officer here at 3HCI, and we're really excited about this webinar today. If you had the opportunity to see this in action at one of our LiveWorks events, really incredible. Joining us from PTC, Andrea Francis. She's a solutions consultant at PTC and also an application engineer. So Andrea, we can see your screen. Really a pleasure to have you. Excited to hear what you have to say, and I will stop talking and hand it over to you. Thank you very much.
Yeah, thank you, Leslie. And hello, everyone. Welcome to this webinar. As Leslie said, my name is Andrea. I work as a solutions consultant at PTC. And today we're going to be talking about generative design. So, what is generative design? It's the ability within your CAD system to generate designs autonomously based on system requirements. If you have loads, forces, constraints, different materials that you're trying out, different manufacturing techniques that you're working with, and you want to generate designs based off of that, that's what you're able to do with it, especially in Creo. And first of all, the reason as to why would you even think about using it when you really think about the products that you're making, whether it's a new entire product that you're venturing into, or it's a product that you've worked a lot on and you want to improve and optimize or add other elements to it. You want to drive innovation to those products. Maybe you want to close down the skill gap. Maybe within your teams, you have experts that are maybe on the verge of retiring or they're close to that, and you have a younger workforce that doesn't have the same level of skill and they want to be able to learn and still create designs of top quality, achieving different metrics that you have for it, but maybe they don't have as much ideas to be based off. And you want to do that more in less time. You want to be as efficient as possible. You need to do tools to be able to do that. You want to spend time on quality products, achieving your metrics at the end, achieving your goals with the designs that you're working on, and don't have to iterate a lot or spend a lot of time on it. And that's where really generative design could come in. It is a great tool to do multiple things, whether it's faster creation of products, generating new ideas, sustainability if you're trying to reduce maybe material or the weight of a part. You can incorporate a lot with generative into your design process. Within Creo, what we have is we have two different extensions for generative design. We have generative topology optimization, or GTO for short, and we have a generative design extension, or GDX. GTO as a tool is a generative design tool in Creo. It allows you to autonomously create your designs from a set of system requirements that you're working. These could be a set of loads that you have, constraints, contacts, preferred materials that you're working with, a manufacturing process, and you're generating one singular design based on this singular set of requirements. Now, the difference between it and GDX is, let's say that you have multiple different sets of requirements that you want to generate designs for. Maybe you have different materials that you're working with, or even different manufacturing techniques that you have, and you want to generate multiple designs based on these multiple sets of requirements. That's what GDX allows you to do. It takes all of that functionality that GTO has, so you can still set up your loads, your constraints, your materials, and it allows you to use the cloud to, first of all, simplify the process of generating the designs and expanding on the capabilities that you have. You can generate multiple different designs within a singular study. You can evaluate them, investigate them, compare them together, and then at the end, you get to pick the most optimum one out of all of the ones that have been generated. In terms of capabilities, really what you're starting with is you're laying the setup of your study. You're laying out your goals, you're laying out your constraints, your requirements for the product that you're working on. You're laying out your materials, physics, the manufacturing constraints that you have, and then you would let generative do designs for you. It generates them. It, these are designs that you've probably never thought of before. You can use them as basis for your products that you're working on, whether it's new concepts or ideas that you are working on, or for further refinement of products in the middle of your design process. You can visualize in real time as generative is creating those designs, and you can run as many of these as you'd like. If it's different sets of requirements that you're evaluating, just taking a look at some of the changes that it generates at the end based on those requirements is really incredible to see. You can interrogate those models at the end as well, review them, see any of the analysis results. Maybe you're evaluating stresses, deformation, seeing how changing the weight or removing some of that material at the end is going to affect the strength of your part. Surely you don't want it to compromise on that, but still it's good to check at the end for it. And the way that it works really is generative in Creo utilizes what is called frustum technology. It's a technology that we've bought a few years ago, and it incorporates artificial intelligence in addition to simulation capabilities to really create this generative design tool that we have in Creo. It allows you to set up your geometry, run analysis on it, take a look at the results, and then at the end, get an output, which would be your design or part at the end. You can output results to either a tessellated model or a boundary representation model that you can take for further refinement to be a base of that you're going to be using for your design into Creo. And that's all of the main functionality into GTO so far. Now, with GTX, it's taking all of that functionality that we've talked about, and we're going to add the power of the cloud to enhance those abilities and take that generative design to the next level. The setup is simple. It's as we've talked about before. You're setting up your constraints, you're letting it generate the designs for you. You can evaluate it. The difference here is instead of generating the design within the Creo environment, you're generating it in the cloud. There's a direct connection to the cloud from Creo. You're opening up an embedded browser into Creo. And that's where you're going to be generating all of your designs right in there. You can select through different combinations of manufacturing methods, of materials, and then generate the design right from within there. It allows you to really have a list of or a number of designs at the end that you can go in, evaluate, look at the results for, see if they've achieved the metrics that you're hoping for it to achieve. Maybe you're concerned about the mass or the safety factor or something like the stress or even the volume of the part. You can go in and definitely filter down through the different designs that you're working on. There's different views where you can toggle between table views, card views. There's graphics available. So you have graphs that you can interact with and vary the columns on them, filter down through cross highlight between the results, and really narrow down your parts. If you're starting maybe with 10 different generated designs. You don't want to have 10 at the end. You want to narrow down to either one or two at the end that you're going to work. You can compare your parts, you can share them out as well to others that you're working with, members of your teams. They can view it, they can edit, they can review it, and it allows you to really collaborate with others onto your designs that you're working with. That's what's great about working with generative design into Creo. So after this brief presentation, I wanted to go over just a quick demonstration to show you an example of how you're able to work with it and use the power of the cloud as well to compare your designs, take a look at results, and then get to an end result and to deal with it. And we're going to start by working on this motorcycle assembly as a start. And we're going to be focusing on a steering mechanism for just the sake of the demonstration. You can think of any parts maybe that you're currently working on. These could be bulky parts on vehicles. They could be any product that you're working on. Let's say that you have an initial idea of it or concept of what it's going to piece to and assemble to and the general shape of it. And maybe like this mechanism over here, it works fine with how it's currently at, but maybe it's a bit too heavy for the overall weight of your end result of the product, and you want to try to take some weight out of it. You've already tried, let's say, a few ideas. They may have not been the best ideas to work with because at the end the part wasn't strong enough for the assembly, but it's a great example, or if it's a perfect candidate to use in generative design, because with it you're not guessing anything or trying out random ideas. Instead, you're using the requirements that you have and then laying an end goal for it, and it's just going to generate an idea that's mostly optimal for. So you're not randomly going around trying out different iterations, testing out 10 or 20 or even 50 different ideas on there. It's directly generating for you the optimum idea for that part. And the way that it starts is we start with a simplified part of our seating mechanism or our component that's going to be the base for our generative design study. We would start with what we call an envelope. So this would be the volume of everything within the part that's going to be contained within it. And then we have our preserved geometry. That's going to be the geometry that we don't want changed in our generative study. Maybe it's holes or pieces that connect to an overall assembly that we know are going to be exactly where we need them to be. We don't want them to be changed. Instead, you want to work on the material or the volume around those pieces and see what we can do. And we would start our generative design study in this case. We would start with the starting geometry, tell Creo, this is our main envelope that we're working with. This is the volume that we intend to change or generate a new design. And this is the preserved geometry, the part that we don't want changed. And if you have any excluded pieces as well, maybe there are pieces that you don't want to touch or even have be considered into the study, that's where you would define them. And then it's simply about laying out your physics. It's similar to how you would lay out a simulation study. You would lay out all of your constraints as well. If a part is fixed, if you have any forces or moments on here, you would just lay them out, lay exactly the magnitudes of them, in which direction. There are units that you're working with. And then if you have any contacts as well, you can definitely set up those. And that's the part where you have your physics. Every time you're laying out an additional constraint, it builds off in the generative tree. Here on the left-hand side, you can add as many of these requirements as you'd like. Maybe you're trying out different materials, trying out different manufacturing techniques. Like in this example, we have a case where we're trying out for a milled piece. For example, we want to reduce the overall volume or the weight of this part by 70%. And it's a milled piece, so we have to put that into consideration. And it's of a specific material. Maybe you want to try out an additional material. Maybe you started with steel, with aluminum. Now we want to try out a different type of alloy in this case to add to our study. You can add as many of these as you'd like and try as many cases of them as you feel the need to. You can set up the settings as well of the study. Do you want to run a high fidelity study? Are you optimizing for speed, for detail? And then you would send it to the cloud. Now, the difference between generative topology optimization and generative design is First of all, the cloud itself is with generative design or GDX. So this is the part where you're optimizing for multiple different sets of requirements. With the GTO, you're just setting up one simple set and then generating a design based off that. That's without the cloud. But here, let's take the example of trying out all of these sets of requirements in this case. So I'm going to be logging in. I have a username and password I'm able to log in from. And then it would take us to the embedded browser into Creo, where you can go in and work on your studies. You can set up a singular study on an individual part that you're working on, and you can update it as well. Maybe you've ran it initially on a few ideas or on a few requirements. Now you want to add in an additional material or an additional manufacturing technique. You can update it. You don't have to recreate an entire study just for that. And that's in our case what we're doing. We added in that new alloy material to our case, and we're going to go in, check the box for it. It's in the study setup. We can see all of our design criteria. We have different techniques that we're working with. We have some additive cases, some melt cases. We have a cast case, and then we have all of the materials that we've already generated designs for. Now, the alloy one is going to be the one that we're adding into that study that we want to go in and generate a new design for. And once all of that is ready, we're going to go in and generate those designs. Once it's generated the designs or it's working on generating the designs, we're into what we call the design tab into the browser. This is a tab where you're able to look at the results of your designs. At the bottom, we have here our table with the list of designs that have been generated or are being generated. You have a status or that you're able to monitor at the bottom, monitoring the progress of the study or the design that you're creating. And then you have a visualization on the right or the left-hand side for it. And then at the top, you have your graphs and your results on all of these are really interactive. You can filter down through your data, and they allow you to focus on your designs a bit more. If you have a list of, let's say, 30, 40, even 50 designs on here, it could be hard to filter down through them and really understand which ones would be better to focus on and which ones shouldn't be. These are what the filters allow you to do. You can filter down based on material, based on technique or manufacturing process that you're incorporating. Are you focusing on just the milled ones? Are you focusing on the additive ones, on the casted ones? That's where it allows you to focus on the particular data. And then it helps to filter down through the tables or the graphs as well. You can filter down or even choose a range of values of the results that you have. Maybe you're concerned about safety factors within a particular range and seeing which of the designs fit within that. Same with the mass, the volume, the displacement. It really helps you to narrow down all of those designs to a much more focused group of ones that you would want to be working with. You can take a look at card views as well. If you don't like working with a table view, you can definitely look at those. And then on the graphs as well. So you can pick and choose the types of axes or what metrics go on which axes that you have. And then it allows you to focus on those metrics a bit more as well. Now, in terms of selecting or even directly comparing your designs, maybe you've narrowed down to a group of selections of your designs on it, but to do a much more direct comparison for them, maybe you'd want to compare the stresses a bit more directly, maybe the weights that you have at the end, the displacements. You can compare them side by side into the embedded browser into a Creo. You would go in, select the ones that you'd want to directly compare, and then navigate to the Compare tab. It puts all of these designs side by side in addition to the visual of the CAD. You can filter down through what type of display it is that you'd want to see. Are you looking at the von Mises stress? Are you looking at the displacements? Do you want to animate them as well? Do you care about seeing how these parts are deforming or displacing? And you can definitely interact with them, move them around in different orientations, and all of these are going to be synchronized as well. You can synchronize these users. You can choose not to. You can send them back into Creo if at the end of this evaluation you find that, yes, this is the part that I want to focus on. You can send it into Creo to work on it a bit further. If, if it's just outputting it into a tessellated model or a boundary representation model, and then working off it. Or if you want to 3D print it, do a bit more analysis on it. Do you want to evaluate thermal on the thermal side of things? Do you want to do a bit more of a structural type of analysis? Do you want to use this design as the base for your concept? You're definitely able to do that. And that's the benefit of working with this. You can try out as many of these different designs and GDX as you feel the need to. Pick and choose which ones would be the most optimum to work with. So you're choosing the quality here over the quantity of iterations that you have, and then bring them back into Creo and work on them a bit further. Are they going to be used for concept generation? If you're still at the beginning stages, is it going to be used for refining your product, maybe in the later stages of your design? Do you still want to run further types of analysis on it? Maybe you'd want to combine it with other different capabilities in Creo. You can definitely do that. And you can output that current design to either a tessellated or a boundary representation model based on what you're working on. There's definitely benefits to both. If you're 3D printing, you can work with tessellated. If you want to reconstruct the model or the surfaces as well, you can work with a boundary representation model. And then use other capabilities. Do you want to run a career simulation live study, or do you want to use it for setting up different variations on a design? You can definitely do that. Maybe with the simulations themselves, we want to do more in-depth simulation that what generative itself allows you as an extension. You can definitely bring that in. Are you incorporating it into a mechanism maybe that moves different parts around and you want to see how it moves, how it responds to different load conditions and to different stresses, and how it affects or it's affected by different parts around it? Do you want to maybe compare them out to different types of products that you're working with? Let's say within an assembly itself, you have options where you can customize the different parts that go into that assembly. So you'd want to compare all of those generated designs. Maybe you're comparing their weight or you're comparing your stresses on here. You can definitely set up yours and really use them in various different ways right into Creo. If you'd want to swap them in and out of your larger assembly or your top level assembly, you can definitely do that. But that's the overall bigger picture of how you can use it within your overall design process. It really allows you to explore a broader design space within still your traditional design methods. You're still using your analysis, you're still using your setup, you're just moving in a much more efficient direction than maybe you're used to for it. And that's generative design into Creo. If I really want to summarize what it could bring you, what you can use it for, first of all, it's faster design. You can combine it with optimizing analysis. Definitely you're combining all of those components together, but you're working towards designing at a faster pace than you're used to. It generates maybe new ideas as well that you're not used to. It could help from an innovation point of view to help you differentiate your products, maybe create something new that hasn't been created out there yet, and still reduce a lot in terms of cost, whether it's the cost of the material, whether it's the amount of material that you're using. If you're incorporating sustainability into your design process, maybe reducing the type of material that you're using, changing it, taking those factors into play, the number of parts that you're iterating on, if you're using any physical prototypes or even iterating into CAD. Maybe you're starting with 20, 10, 20, 30 different parts as ideas that you're working with. This could help you reduce them to maybe 4 or 5 that are really of better quality to be based for your entire process and have you not have to waste any time on something that might not work out in the end. And that's really what it's all about. So,
Thank you, Andrea. This is one of my favorite products. I think I mentioned before, people joined at the headquarters of PTC where we can host in-person meetings. And ideally, you can walk through the center and see things in person. And I ran to the site of this generative design where they had a Volvo part. And to be able to see what they've done with something so heavy, reduced it, made it a little bit easier to manage, stronger, et cetera. It's really remarkable to see in person. So if you attend a LiveWorks event, which I hope you do, you can see all of these things in person. It's also nice to see and hear the story, Andrea, of tying things together with the other solution sets that PTC offers us. We didn't have a lot of questions today, so I'm going to ask the team give a once go around if anybody has any questions. I thoroughly enjoyed it. I like the way you tied it to 3D printing and simulation and, how other solutions fit. Maybe you could give us just a quick answer of this one.
mhm.
What industries do you see gaining the most benefit from this product line? I mean, I know the answer, but I'd love to hear your comments on that.
Yeah, that's a great question. I think a lot of industries actually could use this in various different ways. If you're thinking automotive, it could come into different parts of the automotive industry, right? You'd want to reduce so much weight out of these vehicles, even not just different common vehicles, but let's say if it's Formula One as well, type of vehicles, these could be something that could be used with generative if you're thinking on the medical industry side as well, if you'd want to make sure that maybe with prosthetics, um, how it ties together, how it fits together with a person's limbs, how maybe you'd want to add in innovative ways to how it looks as well in terms of aesthetics. There's different ways that you can do it, but these are the industries that I think it could come into.
Right. Now, we have one user that's commenting on something, and I'm about to type back to you and say, I feel your pain as my network just went out yesterday. Sometimes having things in the cloud, there's pros and cons. There's
Mhm.
always pros and cons. I used to ask people, my God, where do you keep your money? And it's not under your mattress, it's somewhere you can get access to it on the cloud. By the way, don't check your bank accounts on a public Wi-Fi. But how does PTC plan to, and you may not have the answer, and we may need to get this answer, with things going to the cloud, um, network instabilities, I think hardwiring to a network
Mhm.
when things are in the cloud. But what is PTC's solution? I don't want to throw a softball at you, Andrea, but um, what are your comments on that?
Yeah, that's a good question as well. It's a really hard question to answer as well, with the way that things have shifted or we're trying to shift them to with the implementation of SaaS, with moving to the cloud. There's a lot of consideration that comes into it, and I personally do not have the answer to that question yet,
Right.
but we can definitely look into it.
Sure. I mean, a lot of client strategies, product strategies are to go to the cloud. And we will have solutions for it. I'm sure that PTC
Mhm.
gets this on a daily basis. We were the first ones essentially to bring 3D to the market. And now if we're going to be utilizing the cloud, there will absolutely be a solution that we can offer. Does anyone else have any? And Hugh, are you using this solution? Is anybody here using this solution currently? And just giving an overview, do you think that this is something that you might like to introduce? If you do, please send a note because what we could do is a follow-on to this particular webinar. And we could do kind of a next phase or something a little bit more unique to your industry. So if you're interested in that, please let us know. We love to hear everything. And myself as the Chief Operating Officer, and actually formerly a staffer at PTC for a few decades. I was one of the early stage people, so I like to take any and all questions, even to the product teams at PTC. They love hearing input and certainly recommendations. So please don't be a stranger. I'm sure that each person knows their salesperson. 3HCI is here. We offer solutions, but more importantly, we help you solve problems with what we offer. Um, we're not just a software sales company, but more of a solutions solver, if you will, and we implement as well. So Andrea, with that, I can't thank you enough. It's what a sheer pleasure to be on this call with you in this webinar. Outstanding demonstration, and we'll see everyone soon.
Thank you.
Thanks, everyone. Enjoy the rest of your day.